Fossils are time machines. They transport us millions of years into the past. Each fossil is a snapshot of ancient life. They reveal creatures long gone from our world. Fossils are more than just old bones. They are the key to unlocking Earth's history. Imagine holding the tooth of a creature that lived 200 million years ago. That's the power of fossils. They connect us to a world we can only imagine. Fossils tell us about ancient animals, plants, and environments. They are the evidence scientists use to piece together life's story. For mammals, fossils are especially important. They show us how our ancestors evolved, from small, furry creatures to the diverse animals we see today. Fossils reveal the steps of this amazing journey. Let's start with a game changer, Morganeucodon. This tiny creature lived 205 million years ago. Its fossils were found in Wales and China. Morganeucodon was not quite a mammal, but very close. It had fur and warm blood, but it still laid eggs. This fossil shows us the transition from reptile-like ancestors to true mammals. Next we have Hadrocodium. This creature lived 195 million years ago. Its fossils were found in China. Hadrocodium was tiny, weighing only 2 grams. But it had a large brain for its size. This fossil shows us how mammal brains evolved. Another key discovery is Juramaya. This fossil is 160 million years old. It was found in China in 2011. Juramaya is the oldest known placental mammal. This fossil pushes back the origin of placentals by 35 million years. How do we know if a fossil is a mammal? There are several key features to look for. The most important is teeth. Mammals have different types of teeth. They have incisors, canines, premolars, and molars. This is called heterodonty. Reptiles, in contrast, often have similar teeth all around. Another important feature is the jaw. Mammals have a single lower jaw bone. This is called the dentary. Reptiles have several bones in their lower jaw. The extra bones in reptiles move to the mammalian ear. This gave mammals better hearing. We can see this transition in fossils. Mammals also have a unique ear structure. They have 3 tiny bones in the middle ear. These are the malleus, incus, and stapes. In fossils, we can see how these bones evolved from jaw bones. Fossils are like pieces of a giant puzzle. Each new discovery helps us build a clearer picture. But how do scientists use fossils to create evolutionary timelines? It's a complex process that involves many steps. Let's break it down. First, scientists date the fossils. They use techniques like radiometric dating. This tells us how old the rocks around the fossil are. Sometimes they can date the fossil itself. This gives us a timeline of when different creatures lived. We can then arrange fossils in order of age. Next, scientists look at the features of each fossil. They compare these to other fossils and living animals. This helps them understand how different species are related. They can see which features appeared first and how they changed over time. This process is called phylogenetic analysis. Section 5. From synapsids to true mammals, major evolutionary milestones. The story of mammal evolution starts long before the first true mammal. It begins with creatures called synapsids. These lived about 315 million years ago. Synapsids were reptile-like, but they had some early mammal features. They had differentiated teeth and a more upright posture. Over millions of years, synapsids evolved more mammal-like traits. One important group was the cynodonts. These appeared about 260 million years ago. Cynodonts had larger brains and probably had fur. They also had a bony palate, which allowed them to eat and breathe at the same time. The next big step was the evolution of the mammal-like jaw. This happened around 225 million years ago. The extra jaw bones moved to the ear. This improved hearing and allowed for more powerful chewing. Section 6. The Triassic Revolution, Early Mammal Diversification. The Triassic period was a time of great change. It lasted from 252 to 201 million years ago. This is when we see the first true mammals appear, but they didn't look like the mammals we know today. They were small, furry creatures that lived alongside dinosaurs. One of the earliest mammals was Adelobasileus. It lived about 225 million years ago. We only have a partial skull, but it tells us a lot. Adelobasileus had a larger brain case than its ancestors. It also had the beginnings of the mammalian ear structure. Another important Triassic mammal was Cynoconodon. It lived about 208 million years ago. Cynoconodon was more advanced than Adelobasileus. It had a fully mammalian middle ear, but it still had some reptile-like features. Section 7. Jurassic development's expansion of mammalian traits. The Jurassic period lasted from 201 to 145 million years ago. During this time, mammals continued to evolve and diversify. They developed more of the traits we associate with modern mammals, but they were still living in a world dominated by dinosaurs. One important Jurassic mammal was Castorocauda. It lived about 164 million years ago. Castorocauda was adapted for swimming. It had webbed feet and a flat tail like a beaver. This shows that early mammals were already adapting to different environments. Another significant Jurassic mammal was Fruitifossor. It lived about 150 million years ago. Fruitifossor was adapted for digging. It had strong front limbs and specialized teeth. This shows that mammals were evolving to fill different ecological niches. Section 8. Cretaceous Innovations, the Rise of Modern Mammal Groups. The Cretaceous period lasted from 145 to 66 million years ago. This was a time of great innovation for mammals. Many of the major groups of modern mammals appeared during this time. But dinosaurs still ruled the Earth. Mammals had to adapt to survive in their shadow. One important Cretaceous mammal was Repenomamus. We mentioned it earlier. It lived about 125 million years ago. Repenomamus was much larger than earlier mammals. It was about the size of a badger. This shows that mammals were no longer restricted to small sizes. Another significant Cretaceous mammal was Zalamdolestes. It lived about 80 million years ago. Zalamdolestes had long legs and was adapted for running. Section 9. Mass Extinction and Mammalian Triumph. The end of the Cretaceous period was marked by a catastrophic event. A massive asteroid hit the Earth 66 million years ago. This caused a global disaster. It wiped out the dinosaurs and many other species, but it also created new opportunities for mammals. Before the extinction, mammals were mostly small and nocturnal. They lived in the shadow of dinosaurs. But after the extinction, the world changed. There were new ecological niches to fill. Mammals were well suited to adapt to these new conditions. They began to diversify rapidly. One of the first mammals to thrive after the extinction was Purgatorius. It lived about 65 million years ago. Purgatorius was an early primate. Section 10. Beyond bones, soft tissue preservation and its significance. Most fossils are bones or teeth. These hard parts preserve well. But sometimes we're lucky enough to find fossils of soft tissues. These are rare and incredibly valuable. They give us information we can't get from bones alone. Let's look at some examples. One amazing find is the fossil of Castorocauda, which we mentioned earlier. This fossil preserved impressions of fur. It even showed scales on the tail. This tells us that early mammals had both fur and scales. Another incredible find is fossilized mammal hair from the Cretaceous period. This hair is about 100 million years old. It was found in amber. Amber is fossilized tree resin. Section 11. The future of fossil research. What lies ahead? The study of mammal fossils is an exciting and ever-changing field. New discoveries are made all the time. Each find has the potential to change what we know about mammal evolution. So what might the future hold for this field of research? One area of growth is in new technologies. CT scans allow scientists to look inside fossils without damaging them. This can reveal hidden structures and details. DNA analysis is also improving. We may be able to extract DNA from ever-older fossils. This could give us new insights into how species are related. Another exciting area is the search for fossils in unexplored regions. Many parts of the world have not been thoroughly searched for fossils. Places like Antarctica and parts of Asia could hold many undiscovered species. These could fill in gaps in our understanding of mammal evolution. Climate change is also affecting fossil research. As ice melts in polar regions, new fossils are being exposed.